So we have played with the sine function to draw some graphs like this one. We created some animation, but they were quite simple. We were moving objects only horizontally or vertically. But we haven't yet tried to draw things in 2 dimensions. We only are changing here y, but the x variable is not depending on any sine functions. So let's see what kind of images we get when we use both x and y, which depend on the sine function. I'm gonna erase all this program and create an animation. I will keep only the a variable. This part I will leave inside the setup function. And from here, let's just leave the y void draw. And I will take for now the color and size, and just we're gonna be drawing some points. And we need an x variable too. So float x equals map. And let's start more simple. So let's just leave here sine of a, and here too, sine of a minus 1, 1, 50 and 250. Or in this case, we can use here just 0 and the width and 0 on the height, so we can get any point on the screen. Well, and this is drawing just a point, but that would be a little bit hard to see. So let's draw an ellipse instead, and that's a little bit bigger. So what are we getting now here? And of course, we are not erasing the screen. We can see it's already doing some diagonal animation there. Background 0. And it's moving from the top left corner to the bottom right corner. Why is this happening? Well, we are using, for both x and y, we're using sine of a. So x and y will be minus 1 at the same time, because they depend on the same angle. So both x and y will be minus 1 at the same time, will be 0 at the same time, and will be 1 at the same time. That's why here they are minus 1 both, here they are 0, 0 both, here they are 1, 1 both. So this animation is kind of boring. What happens if well, first thing, I could add something. I'm gonna add here a +1 to one of the 2 angles. And this is already quite different. Now I'm getting a circular motion. Depends on how much I add here. If I just add 0,1, then the circular motion is hardly noticed. But as I increase this value, you can see it's now an ellipse. And I type here now 0.9. Let's see what kind of, it's getting more and more circular. If I type 1,5. And what now we're getting a motion that looks quite as a circle going around the center of the screen. Now what happens if we try what we tried in the last episode? We just multiply this by some other sin here. Sin a times 0.8. It looks like it starts doing a circle, but then suddenly it's changing the direction. And one thing we can do is we can get rid of the erasing of the background. So now it will keep drawing and drawing all the time. And then we can get these really interesting patterns. When I first discovered this, I spent like 1 week doing experiments, just multiplying different sine functions and adding some values inside like here, or multiplying by some factor. And you can get very interesting shapes. And finally, just to make it a little bit more interesting, let's change the size of the ellipse, also using some sine functions, and the color. So how can we do that? We can declare here 2 more variables, will be the color. Color will be a map of some sine function. And what I'm gonna do is I'm gonna multiply this angle by a very small number, maybe 0.03. So the color will be changing much slower than the motion, for example. And then I need here again -1 and 1 because we are using a sine function which can return this kind of values. And what kind of colors do we want here? Something between 0 and 100 because we are using up here, that's the maximum value we can use now for colors. And what about the size? Float sz is map sine, and here we can do something more complicated. I'm gonna multiply 2 sine functions, so a times 1.7 times sine of a times 2.3, and again -1 1. And what kind of sizes do we want? Let's say between 5 pixels and 30 pixels. So now I have to enter here the sz variable, so the size is no longer fixed but depends on this variable. And the color, I'm gonna use now here the fill color for co, which is my hue value. And what kind of saturation and brightness? I'm gonna use 50-50, so this time it's not gonna be so rainbow-like, it's gonna be a bit darker. And I'm gonna remove the border stroke, no stroke. And let's see, what do we get here? I'm gonna add one more sine function here to get a real surprise. I times 3.1. Now, what do we get? And there is our slowly changing picture. Looks like a very complicated signature. I guess you can just watch this for a long time and be enjoying. Let's also add a value for the brightness. This is hue, saturation, and brightness is this value 50 here. What if I use the same value? Now this is gonna change too slow, I think. So at some point it will become black. I want something that changes faster. So this is brightness. So I'm gonna declare here float b is map sin something. I will use -1 1. What kind of brightness do we want? Something between quite dark. What are we using right now? We were using 50, so I will say between 10 and 60. And then we have to enter here again some values. A what? Times 1.3 times sin of, that's a lot of sins there. A times 4.1. What do we get now? And now it becomes more beautiful. It's nice, these gradients of changing darkness. Well, I'll let you keep this program running for a while and observe what happens.